morning students. Today I am going to teach functions. In relations functions I have finished relations portion part. Now functions. Already you have learned in first PU the definition of function and constant function, definition of constant function, modulus function, step function and domain and range. So in second PU we will discuss types of functions. In types of functions, one function, onto function and bisective function. Okay. So once recall the definition of function. What is the function definition? A relation f from A to B. A relation f from A to B is said to be a function if every element in set A has unique image in set B. For every element in set A has unique image in set B. For suppose A, B, C, this is the set A, this is set B. Relation F 1, 2, 3. Here A is mapped to 1, B is mapped to 2, C is mapped to again 2. Okay. Is this function or what? Here A have the unique image 1, B have the unique image 2, C have the unique image 2. Okay. For every element A, B, C have the images. Okay. It satisfies the every element in set A. Next, it has unique images. So it is function. For every element in set A has unique image in set B. Okay. This is the function. Okay. Is this function or what? Here 1 has image A, 2 has A and C. Here 2 has 2 images. So it's not a function because 2 has 2 images. Actual definition is every element in set A has unique image, but 2 has 2 images. That's why it's not a function. Okay. Next. One is mapped to A, 2 is mapped to B, 3 is mapped to C. Here set A and set B is the function f from A to B. 1 has A, 2 has B, 3 has C. But 4 has no image. So that's why it is not function because for every element in set A has unique image. So it is not a function. Okay. So f is not a function from A to B. If f is function, we will write f from A to B. Here A is called domain of the function. A is called the domain. B is called codomain. B is called codomain. Okay. The set of f images is called range. The set of f images is called range. It is denoted by f of A. The set of f images is denoted by f of A. Okay. So set A, set B. 1, 2, 3, 4. A, B, C, D. 1 is mapped to A, 2 is mapped to A, 3 is mapped to B, 4 is mapped to C. Here, what's the domain here? 1, 2, 3, 4 is the domain. Codomain is A, B, C, D. Set B is the codomain. Range is set of F images. Here, A is the image of 1 and 2, B is the image of 3, C is the image of 4. So, range is A, B, C. This is the range. Okay. These are the first 8 concepts. Okay. So, in second PU, we will discuss types of functions. So, the types of functions. First one is one function or injective function. One function or injective function. Second one is onto function or surjective function. Onto function or surjective function. Third one is bijective function. Okay, some people also called as one and onto because bijective is nothing but if the function is both one and onto, that function is called the bijective function. Okay. First, let us start with one. In types of function, first one is one function or injective function. Okay, the definition of one function or injective function: a function f from a to b is said to be one function if different elements in set A have different f images in set B. That means if you take set A and set B, A, B, C, it's 1, 2, 3, 4. For suppose different elements in set A have different f images. A has image 1, B has image 2, C has image 4. Here, first of all, is it functional or not? It's A, this is A. A has image 1, B has image 2, C has image 4. Okay, every element in set A has a unique image in set B. But here, different elements in set A have different images. Okay, that means no two elements have same f image. No two elements have same f image. Okay, yes, this is one function. Okay, for suppose if you take one A, B, C, X, Y, it is not one function because A and B have the same f image here. A and B have the same f image. Here we are mapped to X, C mapped to Y. First of all, it is function, but it is not one function. What is the one definition? If different elements in set A have different f images in set B, different elements in set A have different f images in set B, but here A and B have the same f images. Okay, is it one or not? It's one. Here, what are the how many elements is there? Here, set A 3. Set for set B 4. Here, number of elements A is less than number of elements is B. Okay. A, B, C, 1, 2, 3. It's one function because different elements in set A have different f images. This is also one function. Here, n of A is equal to n of B. A is mapped to X, B is mapped to X, C is mapped to Y. Is it one? It's not one because A and B have the same f image. So here n of A is less than n of A is greater than n of B. In this case, f is not one. From these three examples, we can conclude that one result. If f is 1, n of A is less than or equal to n of B. If f is 1, n of A is less than or equal to n of B. That's the condition. N of A is less than or equal to n of B. This is the one definition. Okay. Next, the number of functions. The number of functions is n of B, P, n of E. N of B, P, n of E. The number of functions formula is n of B, P, n of E. The number of elements or cardinal number of B, P, n of E. Okay, this is the formula for number of functions. Okay, next. If a function is, how to check the function is or not on. So not 1. Okay, so for just let us take two elements in set A. Okay, for every element x1, x2 belongs to set A. So take the corresponding images are equal. F of x1 is equal to f of x2. Then x1 is equal to x2. This is 1. Okay, if you take two elements in set A. Okay, their images are equal, then the elements are equal, it is 1. Otherwise, it is not 1. Because, for suppose if you take x1 and x2, A, B, x1 image, x2 image, f of x1 is equal to A, f of x2 is equal to b. Okay, these two are equal or not? A equal to b, a is not equal to b. Okay, if these two are equal, it is also a. Okay, then f of x1 is equal to f of x2. That means here x1 is equal to x2, x1 is equal to x2. In this case, function f is 1 1. Okay, just if you show f of x1 is equal to f of x2, then x1 is equal to x2, it is 1 1. For all x1 x2 belongs to domain. For all x1 x2 belongs to domain. It is the 1 1 function. Next, if the function f is not 1 1, that function is called many one function. If function f is not 1 1, that function is called many one. So, many one definition. A function f from a to b is said to be many one. A function f from a to b is said to be many one. At least two elements in the domain has same f image. At least two elements in the domain has same f image in codomain is the many one function. A, B, C. It's x, y, z. A is mapped to x, B is mapped to y, C is mapped to z. First of all, is it function or not? It's function. A, B, C have the f image. A and B, A have unique image, B has unique image, C has unique image. It is a function. Next, it is not one function because here A and B have the same f image. X is the image. A and B have the same f image. It is not one function. If f is not one, that is f is many one function. If f is not one function, it is many one function. Here A and B have the same f image x. So it is not one function. It is the many one function. I have given the definition. What is the definition of many one? At least two elements in set A have same f image. Here A and B have the same f image. This one also many one function. Okay, A, B, C have the same f image. This is also constant function also. So first, this is also many one function. Okay. So number of many one functions. Number of many one functions is equal to total number of functions minus number of one functions. That is, what is the number of functions formula? N of B, P, N of E. Sorry, N of B power N of E. Number of functions is N of B power N of E minus N of B, P, N of E. So total number of functions minus number of one functions is equal to total number of many one functions. So number of many one functions is equal to total number of functions minus number of one functions. This is the many one functions formula. Once again, I repeat the definition of one. A function f from a to b is said to be one function or injective function if for different elements in set A have different f images. Different elements in set A have different elements in set B. Okay, different f images in set B. So it is enough to prove. So for every x1, x2 belongs to domain such that f of x1 is equal to f of x2, then x1 is equal to x2. That is the one function. If the corresponding images are equal, then elements must be all equal. So in this case, the function f is 1 1. Okay, this is the 1 definition. Next definition, onto function. Onto function or surjective function. The definition of onto function is, first of all, take function f from a to b, a, b, c, x, y, z. If a is mapped to x, that is f of a equal to x. Here x is called image of a. X is called image of a. A is called pre-image of x. A is called pre-image of x. Okay. For every element set B has at least one pre-image in set A is called the onto function. Every element in set B has at least one pre-image in set B, that is called onto function. Okay, here first of all it is a function. X has pre-image B, Y has pre-image B, Z has pre-image C. Okay, so here every element in set B has at least one pre-image in set A. Therefore, it is onto function. A is mapped to X, B is mapped to X, C is mapped to Y. First of all, it is not on. So this is the function, but it is not onto function because Z has no pre-image. Z has no pre-image. That's why it is not onto function. What is the definition of onto function? For every element in set B has at least one pre-image. Here X has two pre-images, no problem for that one. More than one image, no problem. Here X has A and B has the pre-images. Here, don't confuse. Here A has image, unique image X. B has unique image X. But X has two pre-images. There are two pre-images A and B. Okay. So, but Z has no pre-image. This is not function. Here, just what's the domain here? Domain is ABC. ABC is the domain. Here, codomain is XYZ. Codomain is XYZ. Range only X and Y. Only X and Y. What is the range? The set of F images is called range. Here, codomain is XYZ. Range is XY. These two are equal or not? These two are not equal. These two sets are not equal. So it is not onto function. If the codomain is not equal to range, it is not onto function. Codomain of F is not equal to range of F, that is not onto function. Here, codomain is XYZ and range is, that is also XYZ. Codomain and range both are same. This is the onto function. Okay, I think another definition first for onto function. Another definition. This is the easy definition. A function f from A to B said to be onto codomain of f is equal to range of f. Codomain of f is equal to range of f. If the codomain of the function is equal to range of f, that is the onto function. Codomain is not equal to range, that is not onto function. Okay. Once again, I repeat the definition. A function f from A to B is said to be onto. If every element in set B has at least one pre-image in set A, that is onto function. Otherwise, it is not onto function. If f is not onto, that function is called into function. That function is called into. I will explain later. So, another definition for this one, a function f from A to B is said to be onto if codomain of f is equal to range of f. Codomain is nothing but B. Range is f of A. Codomain is equal to range. That function is called onto function. This is the onto function definition. Here, for onto function definition, just once observe A, B, C, D. X, Y, Z. A is mapped to X, B is mapped to Y, C is mapped to Z. Is it onto or not? Here every element has pre-image, but D has no image in set B. First of all, it is not function. Okay. For onto function, now this one okay. This is the onto function. Okay. This is onto function. Here n of A equal to n of B. N of A is greater than n of B. Here n of A is greater than n of B. Okay. What about this one? X is mapped to y, b is mapped to z. Is it onto function? Yeah, y has no pre-image. Okay, if you map like this, first of all it is not function because b has two images. Okay, so it is not onto function. For onto function condition, n of a is greater than or equal to n of b. This is the condition for onto. What is the condition for 1 n of a less than or equal to n of b? For 1 n of a less than or equal to n of b. For onto n of a is greater than or equal to n of b. This is the condition for onto function or surjective function. What is the definition of onto? Codomain of f is equal to range of f. Okay, every element in set B has at least one pre-image in set A. That is the onto function. Next, number of onto functions. Number of onto functions. If set A is containing n elements and set B containing 2 elements, number of onto functions is equal to 2 power n minus 2. 2 power n minus 2. Okay. Next, n of b containing m elements. I will discuss this formula in objective form. Okay. So just you should remember this formula. Okay. So n of a is equal to n of b is equal to 2. Set B containing only 2 elements. So at that time, the number of onto functions is 2 power n minus 2. That is the onto function, number of onto functions formula. Okay. So next, a function which is not onto, that is called into function. A function which is not onto is called into function. So in what is the meaning of what is the definition of into? The function which is not onto is called into function. At least one element in set B has no pre-image in set A, that is called into function. A, B, X, A, B, C, X, Y, Z. Is it onto function? Z has no pre-image. Z has no pre-image. It is not onto function. Okay. So then it is into function. It is into function. A function which is not onto is called into function. At least one element in set B has no pre-image in set A, that is also into function. Okay. The number of into functions is equal to number of into functions. This is equal to total number of functions minus number of onto functions. Total number of functions minus number of onto functions. That is the number of into functions. This is the definition for one onto and into. So what is the onto definition? A function f from a to b is said to be onto if every element in set B has at least one pre-image in set A. That is called onto function. Or a function f from a to b is said to be onto if codomain of f is equal to range of f. That is also called onto function. That is nothing but this is range of f. This is codomain. Okay, this is the onto definition. And conditional I have also explained. What is the condition for onto? N of a is greater than or equal to n of b. Okay. Next, bisective. Next definition is bisective function. Bisective. So bisective function are 1 1 and onto function. That one also 1 1 and onto function. Okay. A function f from A to B is said to be onto f. F is both 1 1 and onto. So the function f is both 1 1 and onto, that function is called bisective function or 1 1 and onto function. Okay, so if f is 1 1, what is the condition? N of a is less than or equal to n of b. F is 1 1. If f is onto, n of a is greater than or equal to n of b. If f is bisective, it satisfies both the conditions because f is 1 1 and onto. Here f is 1 1 and onto, then n of a is less than or equal to n of b, and n of a is greater than or equal to n of b. So from these two, n of a, we can conclude that n of a is equal to n of b because f satisfies these two conditions. Then n of a is equal to n of b. The number of elements in set A and number of elements in set B both are same for bisective functions. If f is bisective, then n of a is equal to n of b. Once again, I repeat the definition. A function f from a to b is said to be bisective. Is said to be bisective if f is both 1 1 and onto. So that is bisective function. The number of bisective functions formula. The number of bisective functions. The number of bisective functions is, so n of a factorial or n of b factorial because n of a equal to n of b. N of a equal to n of b. This is the number of bisective functions formula. N of a factorial or n of b factorial. This is the definition of bisective function. What is bisective function means? F is both 1 1 and onto, and condition is n of a equal to n of b. This is the definition for 1 1 and onto and bisective. Okay. If f is not 1 1, that is many one function. If f is not onto, that is into function. Okay. So once recall the formulas. Number of 1 1 functions. Number of 1 1 functions is n of b p n of a. Number of onto functions. So for set B containing only 2 elements, 2 power n minus 2. Here n of b containing only 2 elements. Set A containing n elements and set B containing 2 elements. Next, number of bisective functions. Bisective functions is n of a factorial or n of b factorial. N of a factorial. Okay, so number of onto functions. Number of onto functions if n of a is equal to set A containing m elements, set B containing n elements. Set A containing m elements, set B containing m elements is the formula. It's n power m minus nc1 into n minus 1 whole power m plus nc2 n minus 2 whole power m minus nc3 n minus 3 whole power m contribution up to you'll get n minus n is 0 up to till to n minus n. Okay, this is the formula for number of onto functions. Set A containing m elements and set B containing n elements. Or if set A containing n elements, set B containing 2 elements, for this one 2 power n minus 2. This is the formula. 2 power n minus 2. Okay. So these are the definitions and formulas. Okay.